All right, so we've talked a little bit about the rock cycle. Now I'm going to get into the different kinds of rocks that we will learn about in eighth grade earth science. So the first kind is our igneous rocks, rather. Students, there are two different kinds. We have our intrusive igneous rocks, which are forming in the ground, and we have our extrusive igneous rocks, are rocks that are forming outside in the open air. Okay, the important thing to remember here is the difference again between magma and lava. Lava being outside on the surface, magma being under the ground. So I'll just draw here a little bit of a volcano for you. And with this volcano, we have a little bit of molten rock underneath that is pushing its way up. This, students, is what? It is magma, okay? And as that magma then pushes up, it will then have enough pressure where it then comes out of the volcano, and now it is considered to be lava, okay? So that is the key difference between the two. Lava is going to be extrusive, okay? So I will jot that down for you here. So this equals extrusive. And the other, magma, will give you your intrusive igneous rocks. Intrusive. All right, so intrusive versus extrusive igneous rocks. Students, I want you to understand the difference between the two is that one is going to be cooling quickly and one is going to be cooling slowly. Can you think about which one's which? If it's in the ground, it is insulated by all of the ground around it. So in fact, the rock that's cooling underground is going to cool slowly. So you could say that this is cooling slowly. And when it cools slowly, students, in class I made the example, if you have two teams with about 1,000 blocks apiece, and one team only gets 30 seconds to take all of those blocks and build it into the biggest sculpture that they can. The other team gets about an hour and a half. Which team is going to have the bigger structure? The team that has a longer amount of time, right? The team that has a longer amount of time. That, students, are our igneous, or our intrusive igneous rocks. Those are the rocks that are deep underground. They cool slowly, and so they have small crystals. And the difference then, extrusive igneous rocks, they cool quickly. And because they cool so quickly, they have itty bitty tiny little grains, little crystals that are formed because the crystals don't have enough time to form. And that's just like the group that only has about 30 seconds in order to put their sculpture together. They don't have very much time, so their sculpture is going to be small, whereas the group that had a lot of time, the intrusive igneous rocks, or the group that had an hour and a half, they're going to have a really big structure in comparison. So students, I want you to pause the video right now and I want you to jot in or put in an image over here. Oh, excuse me, I just went to the next slide on accident. I want you to draw your picture right here for intrusive igneous rocks and here for extrusive igneous rocks. All right, our second kind of rocks that we're going to talk about today are our sedimentary rocks. These are rocks that are formed in a couple of different ways. The first kind that I want to talk to you about are this top category up here. It's our clastic sedimentary rocks. This word, it sounds like plastic, but it's not. It's clastic. And these are sedimentary rocks that are formed when you have sediments. So we're talking little sand grains, we're talking rocks, we're talking even bigger rocks, are buried underground. They're compacted and then cemented together over time. So let's say, for instance, students, that you have a river that is flowing here and it's flowing down the way, and within that river you have some sand grains that come flowing along. Let's say that at some point those sand grains, they get deposited on the bank of that river. Okay, so all these little sand grains get deposited. And then over time, you have more sand grains that are coming down the way. I chose a different color. And those are then going to go on top of these. And so if we look here, underground, where this riverbank is, so we're going underground now, you will see, students, you will see that there are different layers of sand over time, or different layers of different kinds of sediment over time as that river has passed by. Let's see, we have our other layer up here, and maybe perhaps over time, or even in the past, we had another layer all the way down here. And then maybe there was another layer all the way down here. And so, students, as you build up layer after layer after layer after layer, there's a little bit of pressure going on here that's pushing down on all of these layers. And over time, they get compacted and they turn into clastic sedimentary rocks. Okay? So that's what a clastic sedimentary rock is. It's formed of sand, it's formed of rocks, it's formed of even larger rocks, like larger boulders and things like that. Okay, so that's our clastic sedimentary rock. Okay, our second kind of sedimentary rock are our chemical sedimentary rocks. Now that's if you ever have a glass at your house, okay, and you have it filled with water, and then over time, you let that water sit and the water evaporates. And so what you're possibly left with then is an empty glass, change my markers here, is an empty glass that then has this like whitish scum around the edge, okay? That whitish scum are minerals that were dissolved in that water that are then left behind as a solid. That is a chemical sedimentary rock. Any mineral that's dissolved in water, that's left over when that water evaporates is going to end up being left behind, and that's going to be a chemical sedimentary rock. This includes halite or salt. Okay? Salt is a very good example of a chemical sedimentary rock. Okay? So any mineral that is left behind after water evaporates, that's a chemical sedimentary rock. And our third category here is our organic sedimentary rocks, right here in blue. They are formed from remains of fossils of once living organisms, and that can include plants or animals, for that matter. Now, if you were in class, you saw the coprolite that I had, which actually, in fact, is a piece of fossilized poop. True story. So you should come and see that in class. Or we also talked about chalk. Chalk is a very interesting organic sedimentary rock. It's actually formed of dead animals. Just let that sink in for a moment. But for truth, for reals here, chalk is made of this really cool thing. So in the oceans are filled with plankton. When plankton die, plankton are little organisms that have hard shells made of calcium carbonate, but they also photosynthesize in order to get their energy. Plankton die, their shells will fall onto the floor of the ocean. That will create this mud. It's called a lime mud. Now, not limes like you would squeeze to put on tortilla chips or something like that, but excuse me, lime. That's the name of the mud that it contains, because it contains a lot of lime, which is a name for the substance that it is made out of. And so that is then compressed over time, and that then creates the chalk that we use to write on our boards. And so whenever you are writing with chalk, just think, that is actually made of the skeletons of animals that passed away a long, long time ago, or the skeletons of creatures that passed away a long time ago. So an interesting thing to think about with chalk. Also within this group, so we have chalk, we also have coal, and we also have fossils included in this category. So students, what I want you to do now, as you did before, I want you, in these boxes over here, I want you to write or draw your picture or your illustration that will help you to remember these three different kinds of sedimentary rocks. And our last but not least category of rocks, we have our metamorphic rocks. We have two different categories within metamorphic rocks. and we're going to talk about both of them. But the big picture here, the big picture with metamorphic rocks is that they form from heat, and they form from, here I'm going to use a different color for you, and pressure. Okay, so intense heat and intense pressure down beneath the earth. So yes, our metamorphic rocks are all under intense heat and pressure, but there's a slight difference between the two, okay, and we want to make sure that we understand those differences. There are foliated metamorphic rocks, and there are also non-foliated metamorphic rocks. Now, this foliated word is probably one we should talk about first. So foliated means to be in lines or bands, or organized in that way, okay? So if something is foliated, it'll have these bands within it, okay, right here. But if it's non-foliated, what do you think that means? Exactly, so that means that it's all just kind of mixed up. There is no specific order, okay? So this is more of our non-foliated texture here. The other thing to remember, students, between non-foliated and foliated is that more often than not, you will have, with foliated rocks, you will have that rock containing 2 or more minerals within that rock. Now, that isn't always the case, okay? As with everything, there is gray area, but oftentimes foliated rocks will have 2 or more minerals. The other thing then to understand is that non-foliated rocks, or rocks that are more mixed up, will tend to have 1, perhaps 2 minerals within it. Okay? Now, the other big distinction I want to make for you is both of these, both foliated and non-foliated metamorphic rocks, are going to have intense heat and pressure, but foliated metamorphic rocks are actually going to have a little bit more intense pressure, which then causes their 2 or more minerals to align in bands. Okay, just like we had talked about down here below, foliated means that it is formed in lines, whereas non-foliated doesn't quite have as much pressure. That means that the rock texture is all going to be kind of jumbled up. So that is the difference between the two. Slate is our example for a foliated metamorphic rock, and quartzite is our example for a non-foliated metamorphic rock. And students, now at this time what I want you to do is come over to these 2 boxes, and I want you again to draw your 2 images that are going to help you to remember these 2 terms. Awesome. All right, students, now before we leave, let's just recap quick. The 3 different kinds of rocks that we talked about. We talked about igneous, we talked about sedimentary, we talked about metamorphic today. I want you to remember within the rock cycle how this works, okay? Remember in class how we played the game, or you may have done a number of different labs that will talk to you about the rock cycle. The main thing I want you to understand, a rock can go from being a sedimentary rock to being an igneous when perhaps it starts to melt. It melts completely, turns into molten rock, then hardens once it cools. An igneous rock can also turn into a sedimentary rock, though, if the igneous rock breaks down into sediment, is then compressed and compacted over time and cemented together. Now, also though, a sedimentary rock could turn into a metamorphic rock if maybe you have a layer of rocks that go under intense heat and pressure over time, and they turn into a metamorphic rock. Or a metamorphic rock could in fact turn into a sedimentary rock if it breaks down over time into little pieces of sediment, which are then compacted over time. And also, students, could an igneous rock become a metamorphic rock? Is that a possibility? Yes, it is, okay? So an igneous rock could turn into a metamorphic rock by going, again, under intense heat and pressure and forming a new rock, a metamorphic rock. And a metamorphic rock, if it's deep underground, could it come in contact with magma and then melt completely and then turn into an igneous rock? Yes, it could as well. And that does happen, students. So what I want you to see from this example is that the The three different parts of the rock cycle do flow into one another.